So I'd like to tell you a little bit about what's been going on with the S2S project, as well as some of the things that we've been doing at the IRI. So I'll get right into that. So as you know, I'm a co-chair of the S2S project, along with Frederick Vitar, and this is our steering group. There is a steering group members from many of the operational centers, as well as researchers working on S2S from academia, as well as the liaisons with all other WMO groups. And as you all know, the goals of the project to improve the forecast skill and understanding on the subseasonal range between 2 weeks in a season. So really to fill this predictability desert gap that was existing before. And then really it's about improving services. So it's about promoting uptake of these new predictions toward services like for wind energy, for example. And the project is really one of the first joint projects between the World Weather and the World Climate Research Programs, as you know. So it's really trying to connect expertise between those communities. The project's been going since 2015, and we're now into the second phase of it. And that started last year. We have another couple of years to go after this one, so we're well into phase 2. And so what's happening in phase 2? We have some focus on the science side. So there's a set of sub-projects on looking at sources of predictability or that involve coupling between land and atmosphere, ocean atmosphere, the stratosphere and the troposphere, prognostic aerosols. There's more on the MJO and teleconnections. So these they're about the science, but also about improving the models. So the goal really is, we know there's still a long way to go in terms of being able to make skillful forecasts in this range, forecasts that can really be of value. So a big push in the second phase is to see, well, can we make some rapid progress on improving the models and making better forecasts. And so the ensembles there is in terms of, well, how do you set up an ensemble system to, should it be a lagged ensemble, burst ensemble, these types of things. So as before, at the center of it, the core is really the S2S database, which has been the most visible, I think, thing about S2S, the most visible success of the project. And then the other part of it in phase 2 is to have more focus on, well, how can we accelerate the application of these forecasts, their use in terms of being able to quickly assess how good they are in terms of various skill scores that are used in various communities. Really about research to operations. How do we take the research and really build better operations? And toward applications, we have this real-time pilot initiative, which of course S2S4E is one of those. And there are 16 projects there where they have access to the forecast in real time, whereas normally, as you know, these forecasts in the S2S database are delayed 3 weeks behind the real time. So there's 16 projects that are now using this. We don't really know yet. This has been going almost a year now, so it'll go for 1 more year. And we're very much looking forward to seeing, well, what have these projects have been doing? But at the moment, they've really been working on their own. So I'm not. I'm also looking forward to seeing what is coming out of those. The WWRP's Societal and Economics Research for Applications working group have been working with us closely on developing surveys. You'll have received one of those to ask, well, how has the project been going, or what are some of the issues you've been encountering really toward developing some best practice guidelines for that people can use for developing their own subseasonal forecasts. So in terms of the, I think I mostly said this. So really, science service users within the WMO, S2S really sits at this, science, the nexus of science for services and science and modeling development. And it sits very much in this new seamless forecasting setup that is now, that concept is now permeating the WMO's new strategic plan. So the database, as you probably know, there are 11 forecasting centers, global producing centers, whose forecasts go into this, and it's archived at ECMWF and CMA. They're the two official archiving centers, and in the meantime, we also have a copy in the Iri Data Library that I'll show you a little bit more about. Forecasts and reforecasts. The forecast since 2015, and then, as you know, the forecast, it's a database of opportunity. So whatever the various centers have in terms of reforecasts, if they make those, every week or only several times a month, they are archived here. Whatever their ensemble size is for the reforecasts, it's usually different from what it is for the real-time forecast. And one of the challenges of using this database is really that you don't have consistent sets of real-time forecasts and hindcasts. So some of the things we've been trying to do at IRI with constructing daily climatologies from all the models is designed to help people be able to not just use the ECMWF model. So we saw that in our real-time pilot, that most people are using the ECMWF model for their projects because it's known to be the best one, but then there may well be very valuable information in the other models as well. So how to combine together and build multi-model ensembles across projects, that's one of the that's a research theme. And by having this computing daily climatologies and so on, we're trying to make it more accessible. So not only sort of literally more accessible, but in a usable way as well. So in terms of the I'm sorry that this keeps happening whenever I move that little window that you can't see, then I lose that. So I just wanted to highlight that we have had really good uptake in terms of people using the database, and this is just the number of publications. So it's very pleasing to see since the start of the project in 2015, we've really got, in the last few years, a lot of publications now based on S2S data. And if you go to the s2sprediction.net website, and I think if you click on that, it'll take you to the publications. And so you can see for each year, you can get links to all of those publications. I think that's a really valuable thing to have, be able to see what everyone has been working on with the S2S data. It's not a huge amount of data. We're around 130 terabytes by now. So it's really manageable compared to some of the other databases, and one reason for that is because this data is all it's downsampled onto a 1.5 degree grid for all the models. So in terms of what's new about the database, we're very excited that we now have the ocean variables available in the database. So there's opportunities here for looking at air-sea interaction diagnostics, these little maps here of tropical cyclone evolution, systematic errors. It's important goal of the project. to document systematic errors and try to understand where they're coming from, and if the models can be improved to decrease them. Impacts of ocean industrialization can now be looked at, as well as looking at predictability of various potentially useful quantities like sea ice is also part of this data set. And then one can look at possible applications in terms of ocean heat waves, coastal flooding, for example. So what I'm showing here on the right, this is just an example of the data portal, if you will, through the Iri Data Library, so that through a simple scripting language, and we're working on some Python tools that would make this a bit more user-friendly. So at the moment you have to know the IRI's data library scripting language in order to really work server-side with the data, but you can do it. It's very powerful. You can do all your subsetting, choose week 3, 4 lead times, make the average over that, and then here subtract the climatology. You can do it all server-side, and then you can just download a subset of the data, and it makes it much more accessible to work with this data rather than just creating your own dark copy of the S2S database and downloading everything via the Python scripts from ECMWF. You can do a lot of the pre-processing, if you will, or post-processing in Iri Data Library. Then make a map here, for example, of the sea level deviation week 3, 4 forecast from this run from the 27th of August. So you see that sort of La Nina pattern there. But you don't have to just plot the map. You can download all of those forecasts or all of those hindcasts and then do more work on that on your own computer using your own codes. So in terms of those codes, we're trying to put those onto the S2S website so that people can share codes for the work that they've done with S2S, and that's something we need to work on more now. I think I just looked a couple of days ago, and we still don't have much there. There's some of the IRI codes are there. An example of some of the science advances here in terms of there's been quite a lot of work using the S2S database for stratosphere, and that's maybe something that's important for S2S 4E. So for example, here's a forecast, composite 2-meter temperature forecast of anomalies for week 3, 4 after initialization for a particular case, where we can see that the multi-model mean here. So here they have used many of the models, compared well with ERA 4 verification. So how well have we been doing in filling this gap? We know that we have skill in the weather forecasting scale, and that has been improving. We know well these plots from ECMWF showing how their system has improved much, has been continually improving this quiet revolution in NWP. On the seasonal side, it's maybe not so obvious that the forecasts have been improving. This is it's a different score. I mean, in weather, then I tend to look at large-scale anomaly correlation of 500 hectopascal geopotential height fields, whereas we may be looking more on the grid point level when we look at seasonal forecasts, because that of precipitation, say, or temperature, because that's what users care about. So there are very different ways of looking at and verifying forecasts. So that's something we're hoping, within S2S to see that which do you do for the subseasonal, and to see different ways that people are looking at that. But I had put this up just to show that there's not been really that much. If you look at this is IRI's skill from 1997. There's a tropical, it's grid point level, but averaged over the tropics, the skill in the black curve here. And you see that it's not sloping up from 1997 to 2017 to the present. There's no upward slope in this curve. So the forecasts have not been improving on the seasonal scale. and I haven't seen any evidence from other centers to the contrary. In between, we do know that we've had what's really given rise to S2S, this huge advances in MJO prediction. So those skills have been increasing very, very, very markedly over the past 3 years, here showing from 2002 to 2018. So how have we been doing, though, in terms of S2S forecasting of precipitation and temperature? Before I get to that, I'll show this one for individual events like tropical cyclones. So there was a typhoon that hit the Philippines last December, and here's the week 1 forecast in terms of ECMWF strike probability, and you see very high strike probabilities here, over 90%. This is from 2nd December, and the tropical cyclone was during the week of 2 to the 8th, so that's almost 0 lead time there. But what about if we look back then, 4 weeks before, the forecast from the 11th of November? And here you can see that there was actually a good, there was good skill here too. The probabilities, it's much less sharp than you see in the week 1. Here we've got probabilities up to 20 to 30% though, so that's still quite high. And so a lot of the work in the real-time project, pilots or in use of forecasts as well, can we document skill? And then if there is, can you make use of a forecast? Could a decision maker make use of a forecast with this kind of a sharpness? So to have a forecast of 20 to 30% probability, what can you do with that to help avert a catastrophe? And they said that actually in this case that, normally hard-hit Philippines just averted major typhoon damage, through their early warnings, but this really just used the weather forecasting side. So having this subseasonal forecast should enable even more opportunity. And what Frederick has done also was to look through, well, what about the other models? And this is their forecasts from all the models in the S2S database from 7th November. And you can see that some of them did have, interestingly, even the Bureau of Meteorology's low resolution model captured this. Some of them captured it, some of them didn't. But you can if you make a multi-model storm strike probability, you do see quite good skill here. It's not a higher strike probability that we got just from the ECMWF one. Okay, I'll switch now in the remaining minutes to show you a couple of things we've been doing at IRI. So we've made a multi-model ensemble ourselves, a calibrated one, and because we wanted this in real time, we've used the Sub-X forecasts, not the S2S ones, because these ones are available from North American models in real time. And we've got a set of map rooms here where we show the forecasts issued every Friday for the coming weeks, and we show the skill here. And so this is Sub-X. There's 7 models here. It's basically a NOAA-funded project. There's 17 years of retrospective forecasts. We have 1 to 2 years of real-time forecasts now to date. And this is designed to help the Climate Prediction Center with their outlooks. So we have the Sub-X data also now in the Iri Data Library. So if you go there, you can see both S2S data and Sub-X, and you can get them in a similar format, which I think can be very useful to researchers. And then these are the climatologies. So if you go to, we put it on S2S data under ECMWF, go to ECMWF S2S, then you can go to the climatologies. And the ones we have so far are for temperature and accumulated precipitation. So you can get that. I think we have that now for most of the models and now available. So that's something brand new. So their daily climatologies make it much easier to access the to make anomalies, forecast anomalies. And so here's an example here of one that was made for using the ECMWF model. So with some simple scripting, And our goal, as I say, is to have some Python scripts to help you do this as well. You can very easily make anomalies. So for our MME, our multi-model ensemble at IRI, this is the way that we've done it, is to take 3 models that all have forecasts on Wednesdays, CFSV2 and the GEFS and the FIM model. These are all NOAA models. And at every grid point, we calibrate against GPCP precipitation. And then we apply the calibration is done using extended logistic regression. So we want to predict a probability of exceeding a user-defined threshold. And so that's our predictand. And then the predictors that we use for this are the ensemble mean of the model's ensemble mean. So we do this individually for each of the 3 models at every grid point. We do it for precipitation, we do it for near surface temperature, and then we make a simple average of the probabilities, and then that is typically expressed as terciles, but we also do have this flexible format I'll show you in a minute. So this is an example of one of these map rooms. This is a forecast made on 11th of September this year. This is week 3 and 4 for the 26th to the 9th of October. It's expressed in the way that we express our IRI seasonal forecasts. So it's the probability of the dominant tercile category. So if it's blue here, that means there's a higher probability of above normal rainfall. If it's brown, there's a higher probability of below normal in terms of terciles. And if you look at an older forecast like this one, then you can also see, well, what actually happened in terms of the observed percentile. And so it shows that it was actually near the bottom of the distribution over the southwest US. We didn't have much of a forecast here. But if you compare the brown here, here's a successful point over Brazil here. We predicted a higher probability of below normal, and it was below normal. And you can see that many of the places match up, but we by no means capture all of these events. Then you can go in and look at well, what was the climate driver of this, and look at there was an MJO event going on in phase 5. During phase 5, you expect to have convection over the maritime continent, and so you can interpret this above normal forecast in that way. Maybe sea surface temperatures also play a role. So these are some of the things we try to do to be able to explain, well, why is it happening? This is the skill in general, and so in general we have more skill over the oceans, but there's some skill here. This, for example, is for forecasts issued in September, and we can see that there's tend to be high skill using this rank probability skill score over the maritime continent. I'm just going to go roughly through this. I thought this one was maybe interesting to show because, well, how good are we doing in terms of how good the seasonal forecasts are? So what I'm showing here, we can just look at Africa, the ones on the left here. This for a particular season, August to December starts. The seasonal forecast is the skill in RPSS here, and this one here. So we can see we do have very high skill over the Greater Horn, some quite pink colors here. If it's yellow to pink, that means there's some skill. If it's white or blue, no skill. And if you just eyeball these two here, you can see that in general, the subseasonal forecasts in weeks 3 and 4 are comparable in skill to the seasonal ones. Maybe they don't attain quite as high skill in some regions, but maybe there's a broader skill. So basically, I think the message coming out here is, in terms of filling this gap, yes, we're starting to fill the gap. The skill is comparable to what we see on the seasonal forecasting for these bi-weekly averages. This is this select a point map room, so you can actually go in and decide, okay, well, I don't care about terciles. What percentile do you want? I care about the 80th percentile. What's the probability of exceeding that? I can plot that out. Or if I click on the map, I can get, just look at the probability of exceedance at my map. I clicked over Thailand here. And we can see that there's a higher probability in the forecast in green of exceeding all of these quantiles that I may care about as a user. So I focus in this talk on precipitation because it's what at IRI we tend to focus on more, but we have all of this stuff for temperature too. So if you're interested, please go, I'd be happy to follow up with you afterwards to help you sort of navigate where to find those forecasts and to look at them. As my last slide, tuning in earlier in the morning, I caught people talking about weather regimes. So I just wanted to let you know that we've been doing some work at IRI using large-scale k-means derived geopotential height weather regimes. So we have these 4 patterns here. This one's a West Coast ridge, for example. And then here, these are the impacts in terms of precipitation and temperature, just through composite anomalies. But what we're doing, and if you go to our wiki page down here, you can see updated every day. We're taking the forecast from the CFSV2 model, which is run every day, and then we just plot these out in terms of the color, which regime they are forecast to be in terms of these observed regimes. Forecasted time range going out 5, 10, up to 45 days. And we actually have this on the website out to 6 months. And so you can see that, and then this is updated every day. So this is now from the October 25th. So from a couple of days ago. And then each day we have a new one added here. So you can see what the forecasts are doing. And then if you look back over past forecasts, you can see, well, what day did we actually manage to forecast that accurately? And this Pacific ridge, we can see it didn't have predictability beyond about 7 days. But if this West Coast ridge, if that actually happens in the coming days, we will have predicted that about 20 days in advance. So if you're interested, please do check out that link. So thanks very much for your attention. I'm sorry if I went over a bit. So the project, phase 2 project of S2S, focused on better understanding and modeling of these sources of predictability, but lots of focus too on the R2O and the real-time pilot projects. We have some new tools in Iri Data Library, and then I've showed you some of these new calibrated products that we have through our map rooms and then the weather regime forecast. So thanks again. I'm happy to answer any question that if anyone has one.
Thank you very much. So any question? We have a few minutes.
Yeah, this is Andrea speaking. Yeah, thank you very much, Andrew, for this presentation. I'm very nice to see this product on prediction of weather regimes, and also I was interested in the Iri Library new product on climatology that you mentioned. The model climatology. One of the big problems with subseasonal models is that each hindcast has a different length or covers different years. How have you addressed this in the climatologies? Are there for a common period, or each climatology corresponds to the years of each model's hindcast?
Yeah, that's a good question. I think since the models have different the hindcast period, we've used the hindcast periods that are available for the models. And there's a couple of methods we've used. We've used basically a 30-day triangular smoothing, and there's also a harmonics method that's looked for that, that's used for that. So I'm not 100% sure, but I think that it's using whatever's available, since that we couldn't really do it for a common period. I mean, that's something that SubX, they really tried to make the database more homogeneous. So the hindcast period is the same for all the models, and you can access the climatologies there too. That's that issue we have with S2S.
Okay, thank you.
If there's any variable that you're particularly interested in having those climatologies, please do let me know. I mean, we've done it for precipitation and temperature, but it could be done for others as well if there's if people if there's sufficient demand.
Okay, yeah, well, we usually calculate the climatologies ourselves, but in terms of having an homogeneous set to compare different models, it can be interesting.
Thanks for the comment.
We have a question from David Bradshaw. If you can switch on your camera, David.
Hello. Hi, Andrew. Thanks for the talk. I've got two questions. I'll try and pick which one's the best. I guess one that, just to pick up on something that Andrea said there about the climatology aspect. So, I mean, I noticed you had two different climatologies that were displayed on your webpage. There was that triangular one and there was whatever the other one was, I'm afraid. But I just wonder how, this is something we found with me being processing and calibrating and calculating skill scores down to forecast, is there's a million such choices that you make as you're going through the processing. Do you have any thoughts as to how much that matters, how much that actually changes the picture that you get by taking different pathways and choices through that, and whether the kind of the way forward is sort of some sort of standardization of methods, or whether it's always fit to purpose. You do it for the purpose that you want to evaluate the forecast for. Just wonder if you got any thoughts and insights on that.
Yeah, I mean, I guess it's a balancing act, isn't it? I mean, I guess I can't really answer that, but then I suppose it really you know, it shows what the motivation was in terms of sub-X, that they saw what had happened with S2S, and that you know, it is a very heterogeneous database, and so they tried to make one where it would be easier to make multi-model ensembles and have a common period and so on and so forth. I mean, maybe also in the tools, if it's possible to facilitate the use of different assumptions, that can maybe help.
Okay, so we give a question for Llorenç.
Yes, so thank you very much, Andrew, for the talk. I was also curious about the weather regimes. So to give you very briefly a bit of context, in the project we have on one hand tried to verify the accuracy of the forecasts, and on the other hand try to use that to produce end user and impact forecasts. Have you tried to do something of that, just rather than just inform the regimes that you expect that will occur, go one step further and try to forecast the impacts?
No, so the motivation for this was a forecaster guidance tool for NOAA NCEP CPC forecasters. So it was a way for them, we hoped, to picture the forecasts in a concise way. So you could just see this you know, weather regime low order depiction of how their forecasts were evolving. So it was more for them. They make a consensus week 3-4 forecast, and the hope was that this would be informative to them in when they make their consensus outlook for that time, rather than trying to make an impact forecast itself. So we haven't tried to couple together, you know, the precipitation or the temperature impacts with these regimes. And one thing that we are using this now in a California drought project, where they're interested specifically over California in drought. We're using the same tool here, but you know, our regimes are defined on a very large region, so it's not obvious that that would be the best domain to define your regimes on in order to be able to forecast an impact at a particular point. So probably you have similar experiences in terms of, well, how to define these regimes that are the sort of the best fit toward the local impacts versus capturing the sources of predictability, what the models can capture at large scale.
Thank you very much. Yeah, thank you.
There's another question by Albert.
Hi, Andy. Thank you for the presentation. My comment is, I have a question. It's more general about which is your vision on the use of artificial intelligence for subseasonal prediction. So it's more in terms of doing empirical models, or to use it to post-process dynamical forecasts for model calibration, multi-model ensembles with this, because I think that many groups now are starting to work on this. And in the end, what we saw is that almost everyone focused on the new empirical forecast models, but not using the dynamical to improve using this technique?
Yeah, thanks very much for that question. That's one thing I should have had on my slide. As some of you may know or may not, we are planning to have an AI machine learning competition for subseasonal forecasting. So, and in terms of, there's many things, like you were saying, that AI could maybe be used for to improve models such as in parameterization and so forth. But we're focusing on two aspects here. One is in the post-processing. So can machine learning help us make better multimodal post-process products? Like we're using extended logistic regression, but could a machine learning, deep learning algorithm do a better job for that? So that's one. And then the other one is, well, can machine learning actually outperform the models on the subseasonal timescale? And we've seen that some researchers have already started to look at this, and they've been finding on the weather forecasting range that they can't beat the NWP models, but you know, they maybe have similar skills a couple of days with a couple of days lag, something like that. So that competition we're trying to we're developing it now, and so hopefully in the first half of next year that should go live, and then we're hoping that people will you know, there'll be new findings in terms of potential to use machine learning, because we've seen there's a huge interest, and the WMO and the World Weather Research Programs have really been pushing this for S2S to address this. Thanks.